So I wanted to spend some time looking at cybersecurity capability. When we talk about security, what should we do, right? I always say the first thing is that we need visibility. So without visibility, you don't know what you have. If you don't know what you have, you can't protect them. So you must have visibility, know what you have, and know what you need to do to protect them first. And then you implement cyber hygiene, which is to set baseline, understand what OS you have, harden them, set compliance standards, search for vulnerabilities, patch them. These are things that you can do already before any attack happens. Then, of course, to try to prevent the attack, we always say, what is the shield that we have, right? What can we do? So, antivirus use blacklisting, firewalls use packet blocking, packet filtering, then IPS, deep packet inspection, and there are more and more technologies coming out in this space, and customers like to think of it as multi-layer defense. But despite all of that, some of the attacks will always go through. And if it goes through, you must know how to respond to it. So I call it cyber response. So understanding the attack, it's not just actually at the point of attack, most organizations say that they don't even know it's an attack. So the question is, as you detect, how do you validate it's an attack? After you validate and you really understand the attack, then you need to contain it and eradicate it first. Get it out of your system, and then after that only investigate and really learn from it so that you can come back and implement a better posture. What happens if we can inject speed into all of this? How will it improve your defense? So let me start by talking about visibility, because that's the first step, right? Visibility and control of all your assets. So in a legacy endpoint, so I talk about current state, maybe in many parts of ASEAN, I still see this happening. When you need to manage your endpoint, you have a management server. So in this case, it's an asset discovery and inventory type of solution. And these blue dots are your endpoints. So you need a management server so that you can set up a consistent policy to all your endpoints. And then maybe you need a second solution, is patch management. And because you now manage a lot more endpoints, you might need a distribution server. So there's this extra layer that comes in, there's distribution server. And the red dots below show cases where the agent has died or the agent basically did not get installed. And as your number of endpoints go up, you realize that actually this is a common occurrence. The person is on maternity leave, maybe 2 months, 3 months not at work. And because of that, the PC is, the laptop is, locked in a drawer and it never got the agent installed. Or the agent is upgrading halfway and, the user power off the laptop. And as a result, the installation is half done. Or maybe in the endpoint, there's a software that conflict. And because of that, the endpoint agent couldn't run and it died. So we always find that in an endpoint situation, there are always dead agents. And then as we expand into more use case, right, you need compliance, you need to distribute software, you need to manage your threat response, file integrity monitoring, EPP, and even like sensitive data detection. You roll out a very heavy infrastructure, and the endpoint that is not installed continues to be gone because you never thought that it was there. Then meanwhile, other endpoints will die for different solutions. And if you need high availability, you double up your hardware and you can start to see, right? Your endpoint has not changed, but the amount of investment you need to put into infrastructure has increased tremendously. And despite that, you still do not have visibility. That is what we are after for cybersecurity. So to try to get visibility, you pipe all the data and alerts maybe into a SIEM for security and into a CMDB for asset management. And in a way, you still never ever get a good idea of what you have. So I like to paint a scenario, and this is a standard zero day type of scenario. You wake up in the morning, there's a new vulnerability. In fact, just these last 2 days, we see the Kasaya one, right? New vulnerability, exploits are already taking advantage of that vulnerability in a while. Your board of directors want to know what's the potential impact, and then they make some phone calls, call your CIO call CISO, and so on. And finally, you set up a team to assess the impact, right? Generally, the question is, how long will this take? And I say, what does the team need to do to find out which system is vulnerable, how to patch, and what mitigating controls exist? But basically, they go out and ask all the teams, right? Understand where are the vulnerable assets, and then basically ask every single vendor what signature can help. And by the way, the signature may not be out yet because this is 0 day. So to do all of that, it takes a very long time. And then on a second scenario, I like to say, how long does it really take to defend that threat, right? If you have a new attack that comes in, we will be very lucky if a new signature can block the attack. Your timeline, this is a timeline. So your timeline is short, but if your new signature cannot block, some vendors say, let me enhance the security engine. It's a new version now. And then you can detect the attack. So your timeline is a bit longer. But sometimes a new signature and a new engine still cannot block. So you need a brand new security product. And we know that this is a 1 to 2 year time frame because you have to research the attack, understand what happened, think of how to block the attack, test that theory, and then create a new product. So productize. After that, then you start selling, and the market still doesn't know what product you have. So you start sell, market awareness, the end user get to learn what your product does. Then they run a project, an RFP, which may take 3 to 6 months, and implement. So it really is 1 to 2 years before you can block. Every new security product that comes out is 2 years late, actually, because they have to go through this cycle. Okay, so at this point, most customers ask, how is it Tanium can be so fast? Okay, on the right here is a legacy infrastructure that I shared earlier. So you have one server that will talk to your relay server or distribution server, and then each distribution server will control a few endpoints. Now, usually, I think for Indonesia, you have many branches, and your branches are all over Indonesia, which basically means all over the place. If you have to travel by human, it will take a long time. And then now with COVID, we don't want to travel as well. But you would probably put a distribution server in every branch location if you have many branches in order to try to save the bandwidth. So with Tanium's architecture, we simplify this whole thing, all the in-between, all the distribution server we don't need, and we lay out a very, very fast communication architecture first. We call this the linear chain architecture. So let me explain how it works. The server will talk to the first endpoint in the subnet. So usually it's a .1. And if .1 is not there, we'll talk to .2 and so on, right? Basically, we line this up by IP address, and whatever question we ask, .1 will answer, pass on the question and the answer to .2. .2 will also answer, deduplicate, tabulate the answer, and pass on to .3 and so on. And so it goes down the chain until the last person in the chain. The last person has the full result and will send back. So you can see that the server only speaks to 2 endpoints, and it scales to the entire subnet. So that's how we can scale. With one server, we can scale to hundreds and thousands of endpoints. And then the other thing that's important when we talk about desktop management is the discovery. So if a new endpoint join, you will generally join between 3 and 5. We have to be able to discover this endpoint and bring them actively into management. And if you can bring them actively into management, you end up not having to do all the additional work that try to fix it later on, right? All of the work that you need to do becomes business as usual, so that you don't have to mitigate the effect of a missing endpoint later on. So, okay, let's talk about why that discover is important and how Tanium does it different, right? So when you try to discover, some solution use a central scan. So for a central scan, I call it a population census. You put an appliance in your network and then you try and find out who is there. But the issue is that the person may not be there all the time. If he's not in the network, or if he went to a different place, or he went home to work, he's missing, right? So you will miss the count. And then when you try to do central scan, you have to punch through firewalls. Sometimes the firewall will block your scan and you can't find it. So the second way that some solution try to do this is to plant a probe in every subnet. So it's a little bit better because you've already punched through the firewall, you're on the other side. For me, this looks like, having a security guard at the condo, or maybe, there's a guard house before the housing estate, and you're asking the guard, hey, how many people stay in this estate? And you may get a rough idea, but the guard house surely do not know every household that stays at the site. So Tanium, on the other hand, what we do is something called a neighborhood watch. .3 will know .4 exists much faster than everybody else. .3 and .5 will know that .4 comes in much faster. If I ask you how many people stay next door to your house, you're more likely to know, because you're just staying next door. One look over the fence, you're more likely to know how many people. By doing a neighborhood watch, we get a lot more accurate and we find a lot more endpoints. Generally, customers tell us we find at least 10 to 20% more endpoints when they install Tanium compared to what they thought they had. So now that we can find all endpoints, we can see everything and do anything. So see everything, this is a demo that Jimmy just did. We can ask any question. What are the computer names and running process? Okay, so this is very typical. But we could also ask a question, what processes are running today that did not run the last 30 days? And we will know the answer in seconds. Seconds, right? And this is live. We are not doing this through a database. We know this answer live. And then we can take any action. The action can be to apply a patch, to kill a process, to change a registry key, uninstall the application, quarantine the endpoint, And basically for endpoints, we can run any script. And by running any script, we are basically saying we can do anything. So basically this is our Tanium statement. We give you visibility and control in seconds over every endpoint across the largest global network. So our largest customer is 1 million over endpoint. And across the smallest bandwidth, which I thought is very, very important for ASEAN, because many of our branches are in very small kampong with a small bandwidth, right? So I go into the next segment, which is talking about consolidation, streamlining workflow, and helping your cyber hygiene. So now that we have this super fast communication, we basically can put one agent, right? Our one agent can do everything for you. So we build out capabilities. The agent can help you with asset discovery, can help you with inventory, help you with vulnerability management, patch management, software management. The list goes on. And actually, behind our head, we have another 100 things that we like to do. And it's a matter of time when we build them, right? So a single agent, single server can do all that to help you to replace many other types of solution. So alternatively, you would have to roll out many other brands. So let me give you an example why this is how this can help you with process improvement. So usually you would have security team, and the security team will do a vulnerability scan. And after they finish, they export that list and they send a spreadsheet over to the patch, to the operations team to patch. And the operations team will patch and then export back the completed list back to the security team. And the security team will not trust that it's finished, so they scan again. Some will finish, so they can close those cases, but some will still be remaining because maybe the operations team forgot to reboot. And so they send another spreadsheet over to the operations team and it cycles again. And over time, okay, do this round a few times and then if it can close. Okay, this looks like an interesting workflow, but the truth is that, the vulnerability scan, new vulnerabilities will appear every day. So this will need to happen in parallel, right? Many different scan lists will happen in parallel. You can start to see how complex this process is. If I pin out the graph, right? Basically, you have a number of vulnerabilities that you need to patch. And as you patch, the quantity goes down over time. So this is your graph and you're running in parallel. So this is the second flow and this is the third flow. If you can see a flow like this, it basically means that consistently you have this quantity that you have to patch. It never ends, right? It never gets down to zero because you consistently have to patch. But in these 3 lines, if I can patch faster, what happens is that your graph comes down faster, right? With this graph, I think you can see that your quantity remaining to be patched becomes very low. So I'd like to show you a real life example that the customer, when they install Tanium, they didn't have Tanium, they installed and then they were struggling and the patch was still going up. And then when they decide to use Tanium to patch, you can see the quantity come down straight away. This is speed injected into this. Okay, so I wanted to just close off with some summary. So basically our endpoints, the Tanium endpoint platform, we look at the endpoints and we have a single agent on all of the endpoints. Basically, it hits the communication architecture where we have that natural language search. We give you data visualization as Jimmy had shown you earlier. This lateral movement assessment, which we just went through. Open API to partner ecosystem, which I'll share in a short while. On top of that, we build all kinds of use case. So around asset inventory, performance, monitoring, compliance, name it, and we probably have it. And we keep adding on to this. And in the end, you just need to access one console. So the third-party integration that we have, Salesforce, ServiceNow, Splunk, IBM QRadar, we integrate with NAC enforcement because we can discover, right? You discover and then you do network access control enforcement using the network equipment. We absorb threat intelligence from third party and use it to hunt for threats in our organization. And then we also run on cloud if you need us to run on cloud. Many customers found that they save money when they deploy Tanium. So just now I shared the process. If you improve the process, you will save money. I shared that we can discover endpoints. If you can discover new endpoint and bring them under management, then you're managing it as a business as usual, not as an emergency that you need to go and rush because there's an audit failure, because there's a breach. So generally running it as business as usual will save you money. We consolidate a lot of tools. So in that consolidation, we will save you, your endpoint CPU will be saved. We will save the network bandwidth also. And I also share that we remove all of the relay and distribution server, right? So you save a lot of hardware there. And finally, if you can ask, know, and act, you really can fix issues very fast. And that will save money as well.